So this lesson is building triangle proofs. What we're going to do today is fill in the blank proofs. And so our goal is we're going to use the triangle congruence postulates and the vocabulary that we've been working on throughout the whole unit to prove that we have two triangles that are congruent. So for example, this is what you would be given if it was a blank or a fill in the blank proof. You'll see up at the top, we've been given some information about these two triangles, and then our goal is to prove that triangle BCA is congruent to DCE. And you'll notice down here, they've given us a statement and reason column that are already sort of filled in. So our goal is to find the pieces that are missing. So what I always do is I start by what's been given to me, and I mark that on my actual picture. So I've marked BC and DE being congruent with single tick marks and AC and EC being congruent with double tick marks. So what I see here is I know these things are true because they've been given to me. So I'm going to write that in my very first statement because that's information that was given up here at the very beginning. Once I've marked everything that's been given to me on my picture, I'm going to start to assess and see what triangle congruence postulate I could use based on what I have. Now, there's no way for me to know anything about BA in comparison to DE because I don't have enough information. But what I do know is down here, they've said the vertical angle theorem, and that's these two angles around angle C. So I have two sides that I've marked as congruent. I have angle BCA and DCE that I know are congruent because of vertical angle theorem. So I have a side, another side, and then an angle that is included within those two sides. So this would be a side angle side congruence postulate proof. And that's all we have to do for that one. So the next one looks like this. Much less is filled in our proof column, but that's okay. So we're going to start by marking everything we have on our picture. So JK and LK, and then JM and LM have been marked congruent. And I know that those two things are true because they've been given to me in the given of our proof. Now, I know absolutely nothing about angles in this picture. I don't know if any of these lines are parallel. I don't have any information. So my only option is side, side, side. Now you'll notice that KM goes to both triangles. That's the reflexive property. Since that line right there is going to be, if you think about pulling these two triangles apart, KM will go to the first triangle and the second triangle. So that's the reflexive property. So KM is going to be congruent to itself. And then we have our final statement being a side, side, side congruence postulate. Going on to our next one here. They've given me information about angle G and angle I, which has been given to me. And I also know that FH bisects angle GFI. So I know this first thing is true because it's been given to me. And I know that these two angles here, GFH and IFH, are going to be congruent because that's what it means for an angle to be bisected. So I know these two things are true because of the definition of an angle bisector. And then just like we did on our last question, I have this side, FH, that's congruent to itself. And that, again, is our reflexive property. So I have FH being congruent to FH. And now I have an angle, and another side. So I know these two triangles are congruent by the angle side congruence postulate. All right, this one kicks it up a notch a little bit. So this one you'll notice here, it doesn't list everything that's been given right away. This one we're going to kind of walk through step by step and build each piece of our congruence statement as we go. So I know that N and Q are right angles, and I know that because it's been given to me. It says so right here in our given statement. So now the next thing in our proof says that ONP and PQO are blank triangles by the definition of a right triangle. Well, I know they're right triangles because of the definition of a right triangle. A right triangle has a right angle. N and Q are both right angles. Now you'll notice the next thing here in my proof is the reflexive property. Now we have to be careful at this point. When I go to write that this line is congruent to itself, I have to make sure that in my congruent statement that I'm trying to prove, I use the same order for the first triangle as I do the second triangle. So the first triangle has it listed as side OP. The second triangle has it listed as PO. I have them flip-flopped in my congruent statement, but that's okay as long as you have them in the same order on your picture or on your proof. So if you think about if I took these two triangles and I kind of rotated them so that the right angle was in the bottom left-hand corner, and then PO would be that diagonal for one of them, but on the other diagonal, it would be listed as O at the top and P at the bottom. That's why I have to be careful with how I list those line segments. So the next thing I have here is that NO is congruent to PQ. It's already marked on my picture, but I know that because up here it was given to me. Now, I have a right triangle, I have a hypotenuse marked as being congruent to itself, and I have a leg that's being marked as congruent. So I know these two triangles are congruent using hypotenuse, leg. All right. Apparently I forgot to make that tick mark come in later, but that's fine. We'll deal with that when we get there. So on this proof, I see that lines are parallel. So I know since I have lines that are parallel marked on this given, I need to keep in my brain all of those things about parallel lines that we talked about when they're being cut by a transversal. That means corresponding angles, alternate interior angles, maybe alternate exterior angles. Anytime we see parallel showing up in our given statement, I have to keep all of those angle vocabulary terms in my head. So, marking this on my picture, I know ST is parallel to RU, which is my first statement here, and I know that because it's been given. So down here, you'll notice, and again, this is because it's a fill in the blank proof, I talk about angle SRT, SRT, and UTR later on. That means it's not this angle here and this angle here. It's the other side of that. So I'm going to mark them first. I know that these two angles are congruent because I have two parallel lines that are cut by a transversal, and they are alternate interior angles. So what we're saying is if lines are parallel, alternate interior angles are congruent. That's what reason number 2 says. So now I have to make sure I name them correctly. So I'm starting here to get this angle down here by R. It would be TRU and RTS, or STR and URT. As long as you're doing them in the same order, you'll be fine. All right. So now I see that SR is parallel to TU on my statement. I know that because it's been given. The next thing I see here is that angle SRT is congruent to UTR. Those are the angles that are on the opposite line or opposite side of the transversal, but it still follows by the same statement that we gave, or excuse me, the same reason that we had before. I have 2 parallel lines, so that means alternate interior angles have to be congruent. Now, I already kind of gave 5 away having this tick mark here, but I did put this on my picture because I know I'm going to end up using that side because it's the reflexive property. So I have RT being congruent to TR by the reflexive property. It's the same line on both triangles. So now I have 2 angles with a side sandwiched, with a side sandwiched in between. So that would be the angle side angle congruence postulate. So I know it seems, when the teacher does it, I know it seems much easier. But one thing that's going to be helpful is if you think of this like a puzzle, like Clue, for example. Mark everything that you know to be true on your original picture. And then from there, you can put in your given statements. And then if there's a reflexive property or vertical angles or something along those lines, you can start to kind of build yourself to one of those congruence postulates. If you have 2 sides, then it's either going to be side, 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 or side, angle, side. Those are our only options. If I have 2 angles, then I need to look for angle, angle, side, or angle, side, angle. If I have a right triangle, I might want to look for a hypotenuse leg. So the more that you work with these and the more that you practice with these, the easier they will become. But treat them like a game of Clue. You have given statements, and your job is to deduce or infer and prove the rest.